World first, China's space solar farm, 36,000 kilometers above Earth. The concept of collecting sunlight from orbit sounds like science fiction, but it's actually been around for decades. As early as the 1960s, scientists imagined massive solar satellites capturing sunlight in space and beaming it to Earth through microwave transmission. The challenge: technology simply wasn't ready. Rockets were just too expensive, materials weren't durable enough, and wireless power transfer remained a dream. Fast forward to today, those barriers are finally falling. China is stepping up to make that dream a reality, launching what experts call the most ambitious energy project in human history, a space solar power station in geostationary orbit, about 36,000 kilometers from Earth. This altitude allows the station to stay fixed over one location, continuously absorbing sunlight 24 hours a day. Unlike ground-based solar farms, which are limited by weather, seasons, or darkness, this orbital system will operate non-stop, unaffected by clouds or nightfall. It will collect solar energy, convert it into microwaves, and beam it safely to receiving stations on Earth, where it's turned back into clean electricity. According to the South China Morning Post, China's long-term plan involves building a structure nearly 1 kilometer long, a massive array of solar panels floating in orbit. To get there, the country will use its powerful Long March 9 rockets, still in development, designed to carry enormous payloads into space. The rollout will happen in phases. In 2028, a 10-kilowatt test satellite will be launched to prove the technology. By 2030, capacity rises to 1 megawatt. In 2035, up to 10 megawatts. And by 2050, the ultimate goal, a 2-gigawatt orbital plant, capable of powering a mid-sized city. This step-by-step approach is crucial for testing transmission safety, power efficiency, and orbital control. It's a gradual climb toward a system that could, honestly, redefine how the world produces clean energy. So, how exactly can energy collected in space reach our homes on Earth? The magic lies in wireless power transmission, a concept that once seemed futuristic but is now becoming real. Here's how it works. Giant solar panels installed on the orbital station capture the sun's radiation without atmospheric interference. This raw solar energy is then converted into microwave beams and directed towards specific ground-based receivers called rectennas, which is short for rectifying antennas. These receivers convert the microwave signals back into electrical current, feeding it directly into the local power grid. Microwave transmission has several key advantages. First, it eliminates the need for massive power cables, which would be impossible to use from orbit. Second, it can transmit energy safely and efficiently, as the beam intensity is controlled and spread over a wide area. Scientists emphasize that the power density is far below harmful levels for humans or wildlife. Think of it as less intense than sunlight on your skin. To maintain precision, the orbital solar station uses AI-guided positioning systems and automatic beam alignment. It can continuously track the ground receivers even as Earth rotates, guaranteeing stable energy delivery around the clock. Because it's placed in geostationary orbit, the station always sees the same area of Earth, avoiding the downtime typical of low-orbit satellites. Beyond the beam itself, this project is also driving breakthroughs in several fields. For example, lightweight radiation-resistant materials are being developed to survive decades in space. Robotic assembly systems will autonomously build and maintain the kilometer-scale structure, and AI-based monitoring will optimize efficiency and prevent overheating or misalignment. The potential is enormous. A single 2-gigawatt station could generate enough power for millions of homes, day and night, in any weather. For comparison, that's roughly the output of 2 nuclear reactors, but with zero emissions. The implications of this project go far beyond China's borders. If it works, space solar power could become one of humanity's greatest tools in the fight against climate change. Right now, renewable energy faces one major limitation: intermittency. Solar panels stop producing at night, and wind turbines depend on weather. That's why countries still rely heavily on fossil fuels for stable, 24-hour electricity. But a space-based system solves this problem entirely. It generates power continuously 24/7. Regardless of conditions on Earth. Imagine an energy source that never sleeps, no coal, no oil, no emissions. Such a system could drastically reduce greenhouse gas output and accelerate the world's transition to carbon neutrality. It also means countries with limited land or sunlight, like small island nations, could still receive abundant clean energy from space. Economically, the benefits could be transformative. The project would reduce dependence on fossil fuel imports, strengthen energy security, and stimulate new industries in space engineering, AI robotics, and advanced materials. In time, entire orbital power constellations could beam energy to multiple continents simultaneously. But there's also a deeper symbolic meaning here. Throughout history, humanity has always expanded its frontiers, from harnessing fire to mastering electricity. Now we're learning to harness the sunlight beyond our sky. It's a profound step in how civilization relates to the cosmos. Space into a platform for sustainability. Still, challenges remain. Maintaining such a massive orbital station will require regular upgrades, autonomous maintenance, and precise control systems. The cost of launches must also drop further to make it commercially viable. If successful, this initiative could redefine what it means to go green. We won't just place solar farms on rooftops, we'll launch them into orbit. The Earth could eventually receive clean wireless energy from an invisible network of satellites circling above, creating the first true planetary-scale power grid. China's space solar power plant represents a breathtaking leap, not just in energy technology, but in human imagination. It's about building a world where sunlight never stops powering progress, where our energy no longer depends on geography or weather, and where the boundary between Earth and space begins to blur. If you enjoyed this video, don't forget to like, share, and subscribe for more updates on space exploration and scientific discoveries, and don't forget to leave a comment below. Thank you for watching, and see you next time.